Hi, my name is ChenyangSHI. This is a video demonstration of my final project. Self-driving technology has attracted tremendous attention in recent years. One of the central problems in realizing self-driving vehicles is ability to detect and understand objects through the installation of high-speed cameras. These objects include pedestrian, other vehicles, traffic lanes, traffic signs, etc. In this project, I have attempted a solution for traffic signs recognition. My entire workflow can be divided into two parts. The first part is, as indicated by the red dotted box, is traffic sign detection. After image is fed into the pipeline, I pre-process image by first removing the noise using Gaussian blur. Then I apply a color segmentation to retrieve the traffic sign objects, and each sign has a distinct color compared with the background. For example, the stop sign has a red color, and the merge and added lane signs are in yellow. Following the color thresholding step, I use a contour finding algorithm to further isolate the traffic sign and find the region of interest. The second part is about recognition. I feed 1,200 images containing 7 traffic signs of interest into a support vector machine classifier. I rescale the image to be of equal size and use a normalized raw intensity as features. Combining both steps, I'm able to label the traffic sign and draw a bounding box around it. The color segmentation step is done in HSV and HLS color spaces. HSV separates the image intensity from the color component and thus is preferred to RGB color space and used for stop, added lane, signal head, merge, and pedestrian crossing. For speed limit and keep right signs, since majority of the space is filled with white color, I choose HLS color space, while the L, or lightness, best represents white color in the image. Here are the ROI images extracted from Lisa dataset for machine learning. In this project, there are 7 categories with varied image sizes. All 7 classes are balanced with roughly the same number of training instances. Here's a visual representation of the whole process using stop sign as example. Given an input image, I first blur it to remove noises. Then I apply the color threshold to extract the main object. Next, I use a contour finding to further isolate the ROI, feeding that into a support vector machine classifier. I can assign label and draw the bounding box. Here are the positive results for 7 traffic signs using the real-world images. In all these cases, the traffic signs show a strong color contrast to the background. It is more interesting to examine the failed cases. In the top 3 images, the detection algorithm breaks as it cannot find the correct ROI. The reason is that the color of traffic sign blends with that of the background. For example, the added lane has the same yellow color as the traffic lights in the background. The speed limit sign shares the same white color as the truck passing by. The example shown below demonstrates the failure of recognition algorithms, despite it has over 99% classification accuracy in our training. The possible reason is that the training set is still small and not general enough to predict all real-world scenarios. Besides, the training samples are grayscale images, making it challenging to predict real-world color images. There are a couple of thoughts for future improvement. One is use a cascade classifier. Then we can do a better job in color segmentation. And finally, it's always preferred to have a large data set for training good machine learning algorithms. Thank you for your attention.